Hello again and welcome. Today we're going to be introducing a very important term which is called acceleration. Actually, it's pretty easy and straightforward, but it needs a little bit of practice to get used to this term. Now, if I want to introduce what the word acceleration means, it simply means that an object is either speeding up or slowing down. So, when an object is changing its velocity, that means it has acceleration. And in the case that an object is slowing down, we can also call it deceleration. Well, it doesn't really matter. The word acceleration is more general. Acceleration can be found using this simple equation. It is saying that acceleration is equal to delta v over delta t. And we already introduced delta v, which is the change in velocity. So delta v is the change in velocity divided by delta t, which is the change in time. So acceleration is the velocity over time. The unit of acceleration is meters per second square, okay? How is that possible? Because we know that the unit of velocity is meters per second, and then we divide it by time, which is second. So it means like it's meter per second divided by second, so it's meter per second square. Now delta v means change in velocity, which means the final velocity minus the initial velocity, and delta t means the change in time, which is the final time minus the initial time. So the equation is very easy and straightforward, but the application can sometimes be a little bit tricky. Important note. This is a very important note because it sometimes confuses some students. When an object has zero acceleration, it doesn't mean that the object is not moving. There's a difference between having zero acceleration and zero velocity. They are two different things. Zero acceleration does not mean that the object is not moving. It only means that it's not changing its speed. Its speed is constant. So, if we have acceleration, that means the speed is changing. If we do not have acceleration, that means that the speed is the same. Okay? Let's do a quick example. Your friend is skiing down a hill at a certain moment. His velocity was 5 meters per second. So at a certain moment, his velocity was 5 meters per second. After 7 seconds, his velocity increased to become 12 meters per second. Find the acceleration. One of the skills that somebody should learn while learning physics is how to extract information from questions. So we're doing it here as simple as that. We're saying that I want to find the acceleration. Okay, the first step, I will write the equation of acceleration, which is the change of velocity divided by the change of time. Okay, and I also know that the change of velocity is equal to the final velocity minus the initial velocity. But how do I know the final velocity and the initial velocity? Well, it said here that my friend started skiing down a hill. At a certain moment, his velocity was 5. So the initial velocity is equal to 5. This is the initial velocity. After 7 seconds, okay, now we're talking about time, his velocity increased to become 12 meters per second. So it's clear that this is the final velocity. So I have the final velocity, I have the initial velocity, and I have the change in time. Why do I have the change in time? Why did I say that 7 is equal to the change in time? Because let's say that when he started moving, at this point, he had a velocity equal to 5 meters per second. Time was 0. Okay, there was no time counting yet. After a certain amount of time, the velocity here became 12 meters per second, and it took me 7 seconds. So I can say that here the final time is equal to 7, here the initial time is equal to 0, here the initial velocity is equal to 5, and here the final velocity is equal to 12. Using or plugging in the numbers, I will have that the answer is 7 divided by 7, which is equal to 1 meters per second squared. Do not forget that the unit of acceleration is different from the unit of velocity. Now, we must know that the acceleration can either be 0, constant, or changing. Okay? The acceleration itself, it can change. It doesn't have to be equal the whole time. But this is something advanced that we will not be covering. We are going to go deeply in constant acceleration. In other words, the acceleration is not changing. It will have a certain value that doesn't change, and we will go a lot more deep in that. Okay? Now let's solve some problems. Question number 1. It says here that an object changes its velocity from 20 meters per second north, okay, this is important, to 10 meters per second south. Okay, now it's talking about velocity, and we know that velocity is a vector quantity. Because velocity is a vector quantity, we know that it must have a direction. Remember that we mentioned in the previous videos that we can give directions signs, and we said if we're going upwards or to the right, we can give it a positive sign. If we're going downwards or to the left, we can give it a negative sign. So it started from 20 meters per second, so this is V initial. It ended at 10 meters per second, so this is V final. The time is 5 seconds, so I got the time, which is equal to 5 seconds. It's asking about the average acceleration. Now, I know that the acceleration is equal to delta V divided by delta T. Now, what is delta V? I know that delta V is equal to V final minus V initial, okay? But V initial here is equal to 20 and V final is equal to 10. But it's important to remember that. In this case, it was going upwards or north, it had a positive sign. But here it's going south or downwards, so it has a negative sign. So here it's important to remember that 10 will have a negative sign. So V final is going to be equal to minus 10 minus, from the equation, 20. Is 20 positive or negative? No, it's a positive value, so it's minus 10 minus 20, and we will have a velocity equals to minus 30 meters per second. Can velocity be in a negative sign? Yes, this means that it has a certain direction, because we know that velocity is a vector quantity and it must have a direction. So the direction of the velocity is negative and it has a magnitude of 30. So I found delta V. What about T? T, it's clear here that it's 5 seconds. So I will just plug in the numbers. I can say that the acceleration will be equal to negative 30 divided by 5, which is equal to negative 6 meters per second square. Again, what does this negative sign mean? It doesn't change anything. It only gives us the direction of the acceleration since it's a vector quantity. Now let's see our choices here. 0, 2, 4, 6. See, here he didn't even mention the direction. It doesn't matter. That doesn't mean that our answer is wrong. It just says here that he did not take the direction into consideration. So the answer is clearly D. Next question. A car is moving at a speed of 100 meters per second and it's going east. Now the car increased its speed to 120 meters per second, also east. So there is no change in this sign. Now the acceleration of the car is, well, again, acceleration is equal to delta V over T. We're going to extract the information from the question. Delta V is equal to V final minus V initial. Okay, what is our final speed? Well, it says that it was 100 meters per second. Now it's 120 meters per second. It says that it's going east, so we know that east is a positive value. V final is equal to 120 minus V initial, which is 100. So it's equal to 20 meters per second. And what about time? Time is 5. It's clear. So we can say that the acceleration is 20 divided by 5, which is equal to 4 meters per second square. Let's see our choices. Yes, and the answer is C. Another quick question. A cyclist in a race was moving at a speed of 5 meters per second. He accelerated at a rate of 1 meters per second square for 3 seconds. What is the cyclist's speed right now? So this time he's not asking about the acceleration. He's asking about the speed. Okay, I know that acceleration is delta V divided by delta T. This time I have the acceleration. The acceleration, it's here. The acceleration is here. It's equal to 1 meters per second square. And I also have the initial velocity, which is equal to 5 meters per second. So let's do it like this. I know that the acceleration is equal to 1. So 1 is equal to delta V over delta T. Okay, let's continue the answer here. Again, I know that the acceleration is 1. This is equal to delta V divided by the time. The time here is 3. I can do a cross multiplication and find that delta V is equal to 3 meters per second, but it's not asking me to find delta V. It's asking me to find what is the cyclist's speed. What is his speed right now? Well, I know that delta V is V final minus V initial, right? So I can say that V final minus V initial, it's equal to 3 meters per second. Now, what I'm looking for is V final, because I know that V initial was already given in the question, which was equal to 5. So V final minus 5 is equal to 3, and I can find directly by adding 5 on both sides that V final is equal to 5 plus 3, which is equal to 8 meters per second, and we can see that the answer here is D. Well, that's some questions. Questions are getting more deeper right now, so tune in the next videos. We will be solving more problems and introducing more important topics. See you then.